So today we're going to extend what we know about polynomials and what we know about synthetic division to help us find factors. So let's just do a quick review here on factors and what they mean. Last unit, when we did quadratics, we would take this quadratic equation and factor it. And once we found the factors, if we set y equal to 0, when we solved for x, these x values, since y was 0, told us our x-intercept. So by knowing factors, that helps us find our x-intercept. So for instance, on this one, I would say that I had a 0 or a root at -3 and a 0 or a root at -4. So these solutions, after I factored, told me where my graph was going to cross the x-axis. It would tell me my zeros. So let's take that knowledge and apply it towards polynomials. So let's start with this first example here. F of x equals 2x cubed plus 11x squared plus 18x plus 9. So if I'm told that I have one 0 at -3, what that tells me, if I know a 0 is at -3, I know it crosses the x-axis at -3. I also know if -3 was a 0, then x plus 3 would have been the factor that gave me that 0. And we know that from when we did this problem up here. X plus 3 was the factor that went with -3 as a 0. So once we know that -3 is a 0, I can use that in synthetic division to find more zeros. So since the factor is x plus 3, I know that the 0 is -3. So remember how we talked about putting the opposite right here? So I'm going to use the coefficient of each term. So if I put in -3, if that's the input value, let's see what the output value is. Bring down the first term, multiply, add, multiply, add, multiply, and add. Hey, I like this. If I put in -3, I get out 0. So that means there has to be a point at -3, 0 on this polynomial. And I already knew that because they told me that one of the zeros was -3. So this was 2x cubed to start with, and I factored out an x. So what I would be left with is 2x squared plus 5x plus 3. And if I want to find the zeros of this, I'm going to set it equal to 0 and factor. So I have 2x, x. This would need to be a 3 here and a 1 here. And they both need to be plus. So I know that -3, 0 is a 0. I know that the other factors are 2x plus 3 and x plus 1. So x equals -1 is another 0. And the other 0 is where 2x plus 3 equals 0. So 2x equals -3, so x equals -3/2, which is -1.5. So I have a 0 at -1.5, I have a 0 at -1, and a 0 at -3. I know that this is positive, and that's odd, so this end should go down like that, this end should go up like this, and then this is probably going to do something kind of interesting in between like that. So that goes through all those places. So I found the 3 factors of this, and I found the 3 zeros of this polynomial. Let's do another problem. So here's the polynomial. F of x equals 3x cubed plus 14x squared minus 28x minus 24. And I'm going to be told that one of the zeros is negative 6. So if I put in negative 6, the output is 0. So this means that one of the points that works on this is negative 6, 0. That's one of the zeros. It also means that the factor that goes with this is x plus 6. So I know one factor is x plus 6. I should have a couple of more factors because I know I need to have 3 zeros because this is x to the third. So I'm going to use the first 0 I have to help me get this down to an x squared polynomial. So in my synthetic division, I'm going to have negative 6 on the outside, and I'll have 3, 14, negative 28, and negative 24. What my hope is that since negative 6 is a 0, what I should have is a 0 right here when I work this out. The input's negative 6, the output is 0. Let's bring down our first term. Multiply, add, multiply, add, and multiply. And this is good. Negative 24, positive 24 is 0. So input negative 6, output 0. So since this was x to the cubed, what I have left is 3x squared minus 4x minus 4 equals 0. So I want to see if I can find the other two zeros from this. So I'm going to check to see if it factors. 3x and x. And I think if this is 4 and 1, that should work, because this would be 3x and 4x. Well, I don't think that works. I think it's going to have to be 3x plus 2 and 3 and x minus 2. That should work, because that would be minus 6 and plus 2. Okay. So I'm going to have a 0 where 3x plus 2 equals 0, and a 0 where x minus 2 equals 0. So x equals 2 is another place where it crosses the axis. So I have zeros at negative 6, 0, and 2, 0. The other place that it happens is where 3x equals negative 2. So x equals negative 2/3. So the other 0 would be negative 2/3, 0. Those are my 3 roots for my 3 x-intercepts.